let's start with that first question. How can you tell if it's ionic or covalent? Because that's the first question you should ask, right? When I give you a compound, because again, your quiz is going to be all mixed problems. When I give you a compound, how can you tell if it's ionic or covalent? Because that's going to tell you what rules you need to use. Excellent, right? So first up, you're asking yourself, is it ionic or covalent, right? How is it going to be ionic or is it going to be covalent? If it's covalent, by the way, you have a flow chart just like that in your book, so you don't really need to write this down. If it's covalent, it's going to be binary, because really, we are not going to be exploring any covalent compounds this semester that are not binary covalent. So it's going to be binary and consists of two nonmetals. So that's how you will be able to tell if it is covalent. Now, what about ionic? How can you tell if it's ionic? Right? How can you tell if it's ionic? If it's binary, right? If it's a binary ionic compound, right? If you have a binary ionic compound, it should be a metal and a non-metal. What is the other type of ionic compound that we learned about? If it's not, polyatomic. How can you tell if it contains a polyatomic ion? What was the strategy I taught you? How can you tell if it contains a polyatomic ion? It's going to have more than what?
2.
Yeah, more than 2 different elements. So if you ever see a compound that has more than 2 different elements, you know you have a compound which contains a polyatomic ion. Now when it comes to specific rules, there is one thing with ionic compounds you do need to watch out for. What types of metals do you need to watch out for? What types of metals do you need to watch out for? They have special rules when you're naming them.
Aluminum, zinc, and silver.
Those are the exceptions. Aluminum, zinc, silver, the alkali metals, and the alkaline earth metals. Those are the exceptions. Every other metal is multivalent and requires Roman numerals using the stock system, right? So make sure you keep an eye out for those multivalent metals. So use stock system for your multivalent, right? So whenever you're given a compound name or formula, you need to ask yourself first, is it ionic or covalent? Because that completely changes how you address the problem, right? With covalent compounds, what are you going to be using that you don't use with ionic? If I was going to name a covalent compound, say it was C2H6, how would I name that compound? Let's see who here watched the video yesterday. C2H6, how would I name that compound? Yeah?
With Greek.
Yes, the Greek prefixes, and what is it?
Dicarbon hexahydride.
Excellent. Dicarbon hexahydride, right? So the naming rules for covalent ionic are very different. You would use Greek prefixes with the covalent compounds. So very important that you can identify is it ionic covalent. Now again, if it's ionic, if it's binary ionic, you are going to use your binary ionic naming rules, watching out for those multivalent metals. And if it contains more than 2 elements, you know it contains a polyatomic ion. And if it contains a polyatomic ion, where are you going to look to find the charge? No, the Roman numerals for the multivalent metals. If your compound contains a polyatomic ion, let's say it was like this. Where would you look to find the charge on your polyatomic ion? What polyatomic ion did I just draw there, by the way?
Sweet.
Sorry?
Phosphate.
Yeah, phosphate. Where'd you look, Kiara?
On periodic table ions.
Periodic ions, yeah. So the third page of your periodic tables there, you have that table of ions. Whenever you have more than 2 elements, here we have copper, phosphorus, oxygen, you need to go find that polyatomic ion and you need to figure out its charge. So, really important that you're able to determine these things, because I'm not going to be telling you this is a multivalent metal, this is an ionic compound, this is a covalent compound. You need to be able to tell just by looking at the compounds. So, really important, you do a bunch of practice this week, doing those mixed practice problems. You have some in your workbooks and in that bonding booklet I gave you. Because you will be giving a quiz where you're going to have a bunch of stuff mixed together. Right? What if I gave you, let's just do some examples quickly. Let's say I gave you this. Let's say we have that. Let's say that. Let's say that. Let's say something like that. What types of compounds do we have here? What type of compound is this? Yeah, that's a covalent compound. How do you know?
Just 2 metals.
2 nonmetals. Excellent. What type of compound is this? Is it ionic or covalent? It's ionic. How do you know it's ionic?
Metal and non-metal.
Metal and nonmetal. Now, would I name this iron oxide? What do you think? Yes, I see some heads shaking, yes. What would I be missing if I named that just pure iron oxide? What would I be missing? The Roman numeral, right? Because it's a multivalent metal, so that's iron 2 oxide. What about this one here? It's ionic because it's a metal and a non-metal again. And is sodium a multivalent metal? Does sodium always have the same charge? Yeah, what's sodium's charge always?
1.
1. You don't need to list a Roman numeral because it's one of those exceptions, right? The alkali metals, the alkaline earth metals, and then aluminum, zinc, silver are your metals that do not require the stock system, okay? What about this one here? Is it ionic or covalent, first of all? It's ionic. And what's unique about this one here? Sorry?
More than 2 elements.
Yeah, there's more than 2 elements, right? We have 1, 2, 3, 4. I'm counting nitrogen kind of twice here, but that's fine. We have 4. So what does this contain? It must contain polyatomic ion. Which ones does it have? Ammonium and nitrate, that's right. This would just be ammonium nitrate, that's how we would name it. Because do we ever change the name of our polyatomic ions? No. What about this one here? Ionic or covalent? It's ionic. It's going to be an ionic compound. And what are some things you notice? Does it have a polyatomic ion? It does, right? Because it has 1, 2, 3 different elements, so you got to look for that polyatomic ion. Which one does it have? Sulfate. And is vanadium, V, is that one of the multivalent metals?
Yes.
It is. So you would need to use the stock system. You'd have to use those Roman numerals. That's vanadium 5 sulfate. Okay? So again, you're going to be given mixed problems that look like this. You have to be able to tell what type of compound it is and what you need to do. As a little tangent, I we're going to move now on to counting atoms. So if you want to turn to page 25 of your workbooks, today's going to be a little grade 9 review. Grade 9 review for you. So I'm just going to work through the examples you have there. So first off, it says the symbol of an element represents one atom of that element. So if we have Na, just Na, what did I say about ones in chemistry? We don't write ones in chemistry. So if there is no subscript, you assume that you have one of that atom. So if you see just Na, that is going to be one atom of sodium. Right? So just Na would be one atom of sodium. Now, if I put a subscript there, for example, if I put for hydrogen a 2, that 2 tells us what? In our compound, there are 2 hydrogen atoms. Right? So the subscript will tell you how many of each atom is in your compound. So there's 2 hydrogen atoms. And this is something that you already know, right? You should already know, because we've been working with chemical formulas quite a bit. Where things get a little bit different, however, is where we start adding in, say, polyatomic ions and coefficients. So now let's look at a compound that contains a polyatomic ion. So Mg3PO4 2. Students will often get confused when counting atoms when you have polyatomic ions. But what does this 2 here actually represent? Yep.
The amount of phosphate.
Yeah, the number of phosphates you have. So this 2 here is really saying you have 2 PO4s, right? That's what that 2 is representing. So how many phosphoruses are you going to have? 2. How many oxygens? 8. Another way of thinking about this is you can just multiply this outer subscript into your inner subscripts, right? 2 times 4 is 8, 2 times 1 is 2. So let's now count all of our atoms. We already kind of did it, but let's just do it formally. How many atoms of magnesium do we have?
3.
We have 3 because the subscript is 3. Right, so we have 3 atoms of magnesium. How many atoms of phosphorus do we have?
2.
We have 2 atoms of phosphorus. And how many atoms of oxygen?
8.
We have 8. Now this is going to seem kind of redundant and kind of ridiculous, just like it probably did in grade 9, but it's super, super, super important, because once we get into making those recipes of chemistry, our ingredients that we start with have to equal those ingredients we end with. We can rearrange the ingredients, but the things that make them up, the matter, the amounts cannot change. So we are going to get into that in a little bit, but really important that you're able to accurately count atoms. Lastly, coefficients. What is a coefficient? The number that's in front, right? So if I had 3, C is the example they give you here, that's saying we have 3 of whatever follows. So here we have 3 what? 3 atoms of carbon. Right, 3 atoms of carbon. But what if I stuck instead a 3 here? What is that saying now? Yeah, that's saying we have 3 formula units of magnesium phosphate. Okay? So the coefficient will tell you how many of that thing follows it. So if it was a formula unit, it's saying you have 3 formula units. If it was a molecule, you have 3 molecules. If it's an atom, you have 3 atoms. Now let's do a slightly more complex example. Let's say you had 4, and let's say, let's just rip off the example I used previous. V2, SO4, 5. So, what I like to do with these problems, especially if you're trying to do it all in your head, is I like to say, okay, here we have an ionic compound. Let's figure out in one formula unit, how many of each atom do we have? So just ignore that coefficient in front right now. In one formula unit of vanadium sulfate, how many vanadiums do we have? We have 2. Right, we have 2 atoms of vanadium. How many atoms of sulfur do we have?
5.
Excellent, right? We have 5 sulfates, so we have 5 sulfurs. And how many atoms of oxygen?
20.
We have 20. So in one formula unit, this is how much we have. But we don't have one formula unit. How many do we have?
4.
We have 4. So in 4 formula units, we're going to multiply all these numbers by 4. How much vanadium do we have?
8.
We have 8. How much sulfur?
9.
We have 20. And how much oxygen?
80.
80. Right? So whenever I'm counting atoms, I find that it's easier if you're having trouble and you're doing it, incorrectly. Take a step back, ignore the coefficient in front, say, okay, in one of these, how much do I have? And then you can just multiply by the number of formula units or molecules or atoms. Everyone here learned this in grade 9? No? Yes, no, maybe so, okay. So take some time right now, do the practice problems. If you have questions, let me know, okay?